that US military dominance, which started after World War II, has steadily increased as that of its only real rival, the Soviet Union, gradually declined and became entrenched after the Soviet Union finally collapsed in the early 1990s. Today, while technological advances have enabled some nations to significantly close the gap on the US in certain areas and even surpass it in some cases, a variety of factors combine to keep the US firmly at the top of the military pile. So here's a look at the 7 weapons in its arsenal that keeps the US on top. Of course, a discussion of military might has to start with the thing that keeps it flowing: money. The US has had unmatched financial resources for decades with which to fund its massive military, as well as the research and development necessary to retain a significant and enduring technological edge. Its massive air force and navy includes a fleet of aircraft carriers and nuclear submarines, and a network of bases around the world that no one else comes close to matching, enabling it to project power globally on a scale even its nearest rivals can't contemplate. But it's the weapons they carry that are the real story. It's a fearsome array of firepower with advanced systems to deliver it. We'd be here for hours, if not days, discussing all of the US's world-leading weaponry. So let's get into these magnificent 7 weapons in the US arsenal. We'll start with the one that packs the biggest punch, at least among the ones that have been publicly acknowledged. The most destructive weapon in the US arsenal is the LGM-30G Minuteman III ICBM. This legendary missile, arguably the most destructive in the US arsenal, is one of the US's key strategic deterrents and forms the ground-based leg of the US's nuclear triad. A stockpile of 400 is on constant standby in hardened silos at the 90th Missile Wing at F.E. Warren Air Force Base in Wyoming, the 341st Missile Wing at Malmstrom Air Force Base in Montana, and the 91st Missile Wing at Minot Air Force Base in North Dakota. The current Minuteman III is the product of over 60 years of continuous improvement, with various modernizations and upgrades ensuring the massive missile remains as innovative as when the first Minuteman I was first introduced in the 1960s. Back then, both the missile and basing components incorporated significant advances beyond the relatively slow-reacting, liquid-fueled, remotely controlled ICBMs of the previous generation. Over the years, state-of-the-art improvements and modernization programs have delivered new versions of the missile, with expanded targeting options and improved accuracy and survivability. The missile is powered by 3 solid propellant rocket motors, an ATK refurbished M55A1 for the first stage, or launch, an ATK refurbished SR-19 for the second, or cruising stage, and an ATK refurbished SR-73 for the third stage, or descent. With a total weight of more than 79,000 pounds, this 5.5-foot diameter beast has a range of around 6,000 miles and descends to hit targets at a burnout speed of around Mach 23 or 15,000 miles per hour. As for the warhead, although each Minuteman III can carry up to 3, it's understood that currently they've all been equipped with just a single warhead, either an Mk-12A W78 or an Mk-21 W87. The W78, housed in the Mark 12A re-entry vehicle, has a yield of 335 to 350 kilotons of nuclear explosive, and is believed to use a modern primary with an older secondary design. The more modern W87 is housed in the Mark 21 re-entry vehicle and has a smaller yield at 300 kilotons, but can be upgraded to 475 kilotons using highly enriched uranium, or HEU, in the secondary. It utilizes insensitive high explosives, or IHE, for enhanced safety and security compared to W78. Although no new missiles have been produced since 1978, the US's highly effective remove and replace approach to maintenance means that almost 100% of US stockpiles are ready for deployment. So, just how nasty are these missiles? A single 335 kiloton W78 warhead would produce a fireball approximately half a mile in radius and cause near total destruction within a 2.5 mile radius due to overpressure exceeding 10 pounds per square inch, or PSI, which is sufficient to demolish most buildings. Moderate to heavy damage could extend over 5 miles away, with a thermal flash from the detonation potentially causing third-degree burns to exposed skin within a 5 to 6 mile radius. A single 300 kiloton W-87 warhead detonated over a major city would destroy nearly everything within a 1.86 mile radius, with severe burns and lethal radiation doses affecting areas several miles further, while glass windows could shatter up to 9 miles away. A larger 475 kiloton warhead would expand the area of destruction significantly, potentially resulting in tens of thousands to hundreds of thousands of casualties, depending on the target's population density. And if that wasn't bad enough for the US's adversaries, the US submarine-launched nuclear ballistic missile, the Trident II D5LE, is technically speaking even more powerful, with a 475 kiloton W-88 warhead. And there's a new improved upgrade to the Minuteman in development, the LGM-35A Sentinel, a new ICBM designed to maintain the land-based leg of the triad through 2075. And launching that Trident II D5LE is one of the US's most powerful weapons. It's Ohio-class ballistic missile submarines, or SSBNs. The US's 14 SSBNs means that even if the likes of Russia or China launch a full-scale attack on the US's missile silos and air bases housing its nuclear bombers, the US still can unleash apocalyptic nuclear destruction in response from practically anywhere. However, the US has also adapted 4 of its Ohio-class submarines from nuclear platforms into conventional weapon-equipped platforms. In so doing, they've created arguably the most powerful undersea weapons delivery system on the planet. The US's 4 SSGNs, or guided missile submarines, the USS Ohio, Florida, Michigan, and Georgia, provide the Navy with unprecedented strike and special operation mission capabilities from a stealthy clandestine platform. Armed with tactical missiles and equipped with superior communications capabilities, these SSGNs are capable of directly supporting the Combatant Commander's Strike and Special Operations Forces, or SOF, mission. As evidenced by President Donald Trump's recent efforts to revitalize it, the US military shipbuilding industry hasn't been the most prolific source of success stories in recent years. However, the story of the development of the Ohio-class SSGNs suggests that reports of its demise are greatly exaggerated. All 4 submarines required an engineered refueling overhaul in addition to extensive conversion work. That required close coordination between Puget Sound Naval Shipyard in Washington State, Norfolk Naval Shipyard in Virginia, and General Dynamics Electric Boat Company. It may have been the first time such collaboration had been conducted, but the 4 SSGNs were delivered on time, within 5 years, and within budget. So, what capabilities do the US's SSGNs offer? In a nutshell, unprecedented naval firepower and SOF deployment capabilities. The Ohio-class SSGNs are powered by a singular nuclear reactor, meaning the crew of 15 officers and up to 140 enlisted men can remain underwater for extended periods of time. In particular, they've been optimized for SOF operations, with the capacity to host up to 66 Special Forces personnel at a time. Additional berthing was installed in the missile compartment to accommodate the extra personnel, and other measures have been taken to extend the amount of time that the SOF forces can spend deployed aboard the SSGNs. For example, the 2 forwardmost missile tubes were permanently converted to lockout chambers that allow clandestine insertion and retrieval of SOF personnel, including the ability to accommodate a dry deck shelter. Combined with the submarine's advanced stealth features, these SOF-related customizations make the craft ideal for sneaking into enemy waters and enabling SOF missions undetected. During their conversion, each SSGN received the common submarine radio room and 2 high data rate antennas for significantly enhanced communication capabilities. These additions enhance the ability of each SSGN to serve as a forward-deployed, clandestine small combatant joint command center. But the SSGNs are also deliverers of extreme destruction in their own right. Each SSGN is capable of carrying up to 154 Tomahawk land attack cruise missiles in its vertical launch tubes, while also retaining 4 torpedo tubes for Mk-48 heavyweight torpedoes. Taken together, the combined firepower of the 4 SSGNs represents more than half of the submarine force's total vertical launch payload capacity. The missiles are loaded in 7-shot multiple all-up round canisters in up to 22 missile tubes and have been designed to accommodate future payloads such as new types of missiles, unmanned aerial vehicles, and unmanned undersea vehicles. The tubes can also accommodate additional stowage canisters for SOF equipment, food, and other consumables, extending the submarine's ability to remain forward deployed for extended periods. And speaking of Tomahawk missiles, they're next up in our list of the US's most powerful weapons. And like the Minuteman and Ohio-class SSGN, they're also the product of decades-long modernization initiatives. For over 4 decades, the Tomahawk cruise missile has been the Navy's go-to precision strike weapon, quietly reshaping how the US projects power from the sea. It's a long-range subsonic missile that can be fired from submarines, surface ships, and even a few experimental ground-based launches, hitting targets hundreds of miles inland without risking pilots or ships. A compact mix of aviation and computing engineering, the Tomahawk is part aircraft, part robot, and part precision instrument. But besides being an excellent showcase of the US's destructive power, it also highlights another critical aspect of the US's enduring military dominance: its ability to maintain a technological edge through continuous modernization. After its introduction in the 1970s, the Block 1 and 2 variants relied on terrain matching guidance, while later upgrades progressively improved precision. The Block 3 upgrade, introduced in the early 1990s, added GPS guidance alongside improved engines, greatly enhancing accuracy. The Block 4 upgrade, implemented around 2004, added a satellite data link, loiter mode, and mid-flight retargeting, further improving precision while expanding the missile's mission profile and survivability. The current Block 5 upgrade, which has been active since 2021, extends the range and adds hardened electronics, improved maritime strike capability, and open architecture software for future payloads. This evolution over the decades provides living proof that software and data integration can extend the life of a weapon system to the same, if not greater extent, as new materials or engine. At the same time, the US Navy's framework guiding its Tomahawk upgrades continues to influence how the Navy develops new drones, hypersonic missiles, and next-generation sensors, with adaptability being the key. In its current Block 4 and Block 5 incarnations, as in previous variants, the Tomahawk is massive, with a length of around 20 feet 6 inches, with a solid-fueled rocket booster attached, a diameter of 20.4 inches, a wingspan of 8 feet and 9 inches, and a launch weight of 3,500 pounds including the booster. The propulsion is provided by a Williams International F107 WR402 turbofan engine, which uses TH Daimler fuel and is supported by the booster, which is jettisoned after launch. The Tomahawk is not the fastest missile in the world, flying at a subsonic speed of approximately Mach 0.74 or 570 miles per hour. However, its ability to fly at a low altitude of just 98 to 164 feet above ground level helps it to avoid radar detection and makes it much more difficult to shoot down. And its range of more than 900 nautical miles means it can strike targets deep inland while providing plenty of opportunity for the firing ship or submarine to shoot and scoot. As you'd expect from a missile this size, it packs a serious punch. The BGM-109C and BGM-109E are the most common conventional Tomahawk variants in service today. The earlier 109C carries a roughly 1,000-pound unitary high-explosive warhead using Picrotol H6, while the later 109E employs a lighter, more modern 690-pound unitary warhead with 265 pounds of PBXN-107 high explosive. In either configuration, a single Tomahawk detonation can destroy reinforced concrete structures or modern buildings, create craters up to 20 feet wide, produce lethal fragmentation effects over dozens of feet, and penetrate several feet of earth or light concrete before detonating, depending on the fusing used. Now imagine what a barrage of Tomahawks from just a fraction of the 154 that an Ohio-class SSGN carries could do to a Russian military base, for example. And then consider that all of that damage is likely to pale in comparison with the destruction that the US's most powerful non-nuclear bomb can unleash. the GBU-43B Massive Ordnance Air Blast Bomb, or MOAB for short. The bomb is so powerful that the abbreviation has come to mean the mother of all bombs, and for good reason. Now, the fact that only 15 of these monstrous bombs are believed to have ever been produced tells you that these aren't made for widespread use, like the Tomahawks for example. The MOAB is reserved for extreme operational scenarios where overwhelming force and symbolic deterrence are required. The fear of the weapon is almost as important as its actual destructive power. And fear is certainly an appropriate emotion when contemplating a MOAB being dropped on you, if not outright panic. It's a GPS-guided air-delivered munition measuring 30 feet in length, 40.5 inches in diameter. It has a total weight of approximately 21,600 pounds, with its warhead, the BLU-120/B, filled with 18,700 pounds of H6 high explosive. H6 is a mixture of RDX, TNT, and aluminum, which yields an explosive force equivalent to 11 tons of TNT or 46 gigajoules. It's so huge that it has to be deployed from a specialized Combat Talon II variant of the famous Lockheed MC-130 Hercules transport plane, and in a unique way. The bomb is carried in a cradle on a platform in the cargo hold, and the whole assembly is dragged out to the rear by a drogue chute. When clear of the aircraft, the MOAB is released. 4 movable grid-type control fins on the tail are extended, and the guidance system directs the weapon towards its target, with 2 low aspect ratio wings to increase lift and thereby the gliding range. The MOAB uses a KMU 593/B guidance kit that combines GPS and an inertial navigation system for precision targeting, achieving a circular error probable of around 30 feet. Once it reaches its target, the MOAB is designed to detonate just above ground level to maximize its air blast effect, creating a shockwave over a radius of up to 1 mile in open terrain. It was originally developed for use in the Iraq War at a reported cost of $16 million each and was first tested in 2003, but it's only ever been used in combat once. The incident happened in Afghanistan in April 2017, when the US dropped a MOAB on a network of tunnels operated by the terrorist network ISIS in the Achin district of Nangarhar province. The explosion reportedly resulted in the deaths of over 90 enemy combatants, with no reported civilian casualties. Believe it or not, the US actually has even a heavier bomb, the 30,000-pound GBU-57 A/B Massive Ordnance Penetrator, or MOAB. That's the famed bunker buster bomb that the US dropped on Iran's nuclear facilities during Operation Midnight Hammer in June 2025. While the MOAB is designed as a massive airburst weapon for soft to medium surface targets, such as cave complexes, minefields, and troops or equipment spread over a wide area, the MOAB is built for an entirely different job. The MOAB is designed to burrow deep underground before detonating. That means that, while you definitely don't want to be anywhere near it when that happens, the visible surface effects can actually be less dramatic than those of a Tomahawk strike. By comparison, the shockwave from the MOAB causes damage up to a mile away, making it the more powerful weapon considering both the destructive power and psychological warfare effects. That said, the MOAB is also so huge that it needs a very special aircraft to carry it. The B-2 Spirit bomber spearheads the US's strategic bomber fleet. It's a multi-role bomber that can carry both conventional and nuclear munitions, bringing massive firepower to bear in short time anywhere on the globe. Its low observable or stealth characteristics give it the unique ability to penetrate an enemy's most sophisticated air defenses and threaten its most valued and heavily defended targets. The B-2's low observability is derived from its composite materials, special coatings, and flying wing design, which combine to reduce the aircraft's infrared, acoustic, electromagnetic, visual, and radar signatures. These weak signatures make it difficult for the sophisticated defensive systems to detect, track, and engage the B-2. But reaching within range of its targets is just part of what makes the B-2 Spirit so special. Once it gets there, it has the power and versatility to deliver some serious damage. The power comes from 4 General Electric F118 GE100 engines, which generate 17,300 pounds of thrust each, enabling a maximum takeoff weight of 336,500 pounds, including a payload of up to 60,000 pounds. With an operational ceiling of 50,000 feet, and an unrefueled range of over 6,000 miles cruising at high subsonic speeds, it's capable of extended long-range missions. Proven in combat in Kosovo, Afghanistan, Iraq, and more recently Yemen, the B-2 Spirit can carry 80 500-pound GBU-38 JDAM GPS-guided bombs, or Mk-82 bombs, 16 2,000-pound GBU-31 JDAMs, or Mk-84 general-purpose bombs, 16 AGM-154 JSO glide weapons, or AGM-158 JASSM long-range cruise missiles, and up to 2 MOPs. It can also carry nuclear payloads, specifically up to 16 B-61-7, B-61-11, B-61-12, or B-83 gravity bombs. That's an awful lot of firepower that you literally won't see coming until it's way too late. And it's the same combination of stealth, performance, firepower, and versatility that characterizes the US's most powerful multi-purpose fighter jet, the F-35 Lightning II. The F-35 Joint Strike Fighter, to use its full designation, is a 5th-generation American-made aircraft and one of its most lucrative exports, flown by 20 nations and surpassing 1 million cumulative flight hours. Known for its stealth capabilities, versatility, range, speed, and advanced electronic warfare and avionics, the F-35 is a crucial factor in the US and its allies maintaining the air superiority that they've held for decades. Moreover, as we've seen with weapon systems covered earlier, the F-35 has been designed with adaptability as a core feature. As a result, specialized variants have been developed for the US Air Force, Marine Corps, Navy, and individual export customers, each tailored for specific roles and requirements. For example, the low-cost F-35A variant is built for standard runways of roughly 8,000 feet, suitable for ground-based Army use cases. By contrast, the F-35B, the Marine Corps' Lightning II variant, features short takeoff and vertical landing, or STOVL capability, while the Navy's F-35C variant is carrier-capable, equipped with heavy-duty landing gear and a tailhook. However, all variants are powered by Pratt & Whitney's F-135 engine family, providing approximately 40,000 pounds of maximum thrust. This gives each fighter a range of between 900 and 1,200 nautical miles, and allows the jet to reach speeds in excess of Mach 1.6 or about 1,227 miles per hour. Like the B-2 Spirit, the F-35 uses a combination of wing design and special radar-absorbent coatings to minimize the aircraft's radar cross-section and thus detectability. While in its stealth configuration, the Lightning II can carry 4 AIM-120 AMRAAM missiles for air-to-air missions, or a combination of 4 AIM-120 and GBU-31 JDAM smart bombs for air-to-ground missions. The F-35 can also enter beast mode, carrying up to 14 AIM-120 missiles and 2 AIM-9X missiles for high-intensity air-to-air combat, or a mixed loadout combining air-to-air missiles with ground attack weapons such as 6 GBU-31 JDAMs. F-35s also feature large touchscreens and a helmet-mounted display system that enables the pilot to look directly through the aircraft to see real-time information using a distributed aperture system and a suite of mounted infrared cameras. The Lightning II is also equipped with an AN APG-81 system, active electronically scanned array radar for robust electronic countermeasures. Put it all together, and while other 5th-generation fighters may be closing the gap, the F-35 is still the most technologically advanced 5th-generation platform on the planet today, and the F-35C variant can take off from the US's ultimate weapon, the Gerald Ford class aircraft carriers. For decades, the US's fleet of Nimitz-class aircraft carriers has ruled the world's waves, allowing the US to project power to all corners of the planet in ways everyone else can only fantasize about. The USS Gerald R. Ford, first of the class that bears the same name, ratchets up the advantage by several notches. This truly enormous floating military base is almost 1,100 feet long, with a beam of 134 feet and a 255-foot wide runway, and a displacement of around 100,000 tons. It's practically unsinkable, with doubts about whether even a nearby nuclear explosion could actually sink it. Powered by an advanced nuclear propulsion system with 2 reactors, 4 shafts, and a zonal electrical power distribution system for the carriers, it can stay at sea almost indefinitely. Like all the other systems we've showcased, The key feature of the Ford-class carriers is their adaptability and versatility. For example, the lower decks incorporate a flexible, rapidly reconfigurable layout, enabling various layouts and the installation of new equipment in command, planning, and administration areas. A weight and stability allowance has also been incorporated to accommodate the added weight of new systems that will be installed over the 50-year operational life of the ship. The carrier can carry up to 90 aircraft, including the aforementioned F-35 Joint Strike Fighter, FA-18EF Super Hornet, E-2D Advanced Hawkeye, EA-18G Growler Electronic Attack Aircraft, MH-60RS helicopters, as well as unmanned air and combat vehicles. The aircraft are launched with a state-of-the-art GA-EMS Electromagnetic Aircraft Launch System, or EMALS, and land with the help of advanced arrestor gear. These offer finer aircraft acceleration control, leading to lower stress levels in the aircraft and pilots, providing a slower launch speed for drones and allowing a wider window of wind over deck speed required for the launch sequence. At the center of a carrier strike group, which includes accompanying destroyers, frigates, submarines, and support ships, this is the ultimate non-nuclear weapon. There is simply no other weapon system on Earth that can match the power it can bring to bear, its operational jurisdiction, and its survivability. That is, until the US unveils its next generation of sci-fi weaponry that makes its current batch redundant. We'll of course keep you updated as directed energy weapons, smart missiles, battle robots and the like come online. So make sure you're subscribed to the channel so you don't miss out. Thanks for watching.